Hi, I'm Chelsea, and today I'm going to discuss counterexamples. Counterexamples are very useful for proving that a general statement is wrong, because in order to prove that something is wrong, if you can find a counterexample, then you're done. And counterexamples simply provide one exception to the rule. So the exact definition of a counterexample is an exception to a proposed general rule. Now usually, let's say if your teacher gave you a statement and said prove that it is wrong, in order to do so you only need to prove that the statement is wrong one counterexample. So it can be hopefully something you can easily think of in order to prove that that statement is wrong. So now what I've done is I've provided a few examples to show you how to use counterexamples to prove that a statement is incorrect. The first example I have is pretty easy, and that is all prime numbers are odd. Well, one I can think of right away would be the number 2. So a counterexample to that statement would just be 2, and 2 is obviously an even number, and it's also prime. It can only be divided by 1 in itself. Let's look at the next statement, which actually relates to geometry. And the next general proposed statement would be all quadrilaterals with 4 congruent sides are squares. Now certainly squares have 4 congruent sides, but I can think of another figure would be a rhombus. And a rhombus, if you recall, looks something like this usually, where all the sides are congruent. Okay? But notice how it's not a square because these angles, the angles inside the rhombus, do not have to be 90 degrees. It is a parallelogram, but it is not necessarily 90 degrees. So a counterexample to this statement would be a rhombus. Okay. And then looking at this third and final example that says all altitudes of a triangle are inside the triangle. Well, I can think of an example where we have a triangle, and if we draw an altitude, it actually is not going to lie within the triangle. An altitude, if you recall, for a given triangle is a line segment that goes from an angle perpendicular to the opposite side of the triangle. So for example, and this happens actually with probably all obtuse triangles. So if I draw an obtuse triangle, and if you recall that means that this angle is greater than 90 degrees. If I am to draw an altitude, I'll just label this triangle as ABC, okay, from the altitude from angle A. If I were to draw it inside, I can't draw it so that it is perpendicular. So if I were to extend the opposite side of this triangle to draw the altitude perpendicular, notice how it is actually outside that triangle. And again, that is the definition of an altitude, that it has to run perpendicular. So for an obtuse triangle, this general statement that the altitude of a triangle is inside the triangle is false, based on this counterexample. So that's it for these 3 examples of counterexamples. Sometimes it actually is much harder to come up with a counterexample, but if you can, it's a very easy way to prove that a statement is false if you are questioning it. And that's it. For more information, please visit our website at www.sandersontestprep.com. The link is in the description box below. Thank you.